So I don't know if you guys remember, Rob has been with Microsoft in Phoenix for a lot of years, and then now has moved up to the Azure camp. So you can tell him a little bit more about what you're doing, but certainly a familiar face. So I'd like to have a nice, warm Arizona welcome back for our friends, Rob Bagby, and I'll let you take it over.
Thank you, I appreciate it. Yeah, when I came back from London, I took a 4-year hiatus from Microsoft and moved to London. And when I came back, I took a job with the same group, DX, but I worked with partners, ISVs. And we work in different categories. So some people have media, some people have BI and analytics. The category I work with exclusively is containers. And so what I'm going to be talking about today, I think, and how do I get my slides up? No, we don't need the slide. I guess I can. There you go. So what I'm going to be talking about today is containers. And how many of you are actively working with containers today? How many of you have heard of it and are massively confused by all of the overloaded terms and no idea what's what? And that's really what I plan on kind of addressing today. If you take a look at this slide, I took a stab at building a tag cloud of all of the wording that you'll see. I'm doing something wrong. This is live, by the way. All right. Of all of the kind of technologies, and my goal over the next hour is to help demystify this, so you can have an understanding of hopefully what containers are, what the benefit of containers are, what some of the use cases are of containers, but also all of the offerings that exist out in the Microsoft ecosystem. Okay. And so hopefully, if I hit that, we'll be doing well. So I'm going to start off with a container primer, but then I'm going to talk to you about some of the varying offerings that we have at Microsoft out in the containerverse. The Docker 4 offerings. So I'll talk about Docker for Azure, Docker for Windows. I'm going to talk about Windows containers, what they are, how are they different than Linux containers. We'll talk about Azure Container Service, which is our kind of managed container orchestration offering. And then Jerry talked to you a lot about .NET Core. I'm going to show you .NET Core running under one of the orchestrators. I'm going to show you a .NET Core app running on DCOS. I'll talk to you really briefly about the enterprise solutions, Enterprise DCOS and Docker Data Center. And then we'll talk about CI/CD, which is a pretty common use for containers today. And hopefully by the end of the talk, you'll understand why. So if you're not familiar with what containers are, containers allow you to basically deploy your application along with all of its dependencies. That's the biggest benefit that you get out of containers. That's the attribute that I kind of point to as enabling all of the great features you're going to get or solve all of the large problems that containers solved. It's that you encapsulate your dependencies such that you don't have to worry about what's running on the host, because those are encapsulated in that image when you deploy your container. Okay? So what are the benefits that you get? What do I get when I encapsulate my dependencies and I have this unit of deployment that I can move around complete with dependencies? Well, you lose all of those challenges that you have. Hey, it works on my machine. And I know works on my machine, everybody here has probably run into that. But works on my machine isn't just getting me into test, from my machine into test. It goes even bigger, and it's a bigger challenge when you start to get into the enterprise. What about those scenarios where you deploy to staging, and it all works, all your tests work in staging, but then you deploy out to production from staging, which is the exact environment, and it doesn't work. It's the exact environment, I swear it's the exact environment, but it doesn't work. Those problems are solved when you're deploying containers because the dependencies are encapsulated inside of those containers. You don't have to worry about what's out in staging and what's on production. Likewise, imagine the scenario where I'm running a specific version of .NET Core or a specific version of Python, and I build my service, and I deploy it out into my build server, which has that specific version on it, and it all compiles and works. So then developer group B comes along, and they want to deploy a later version for a new feature, the next version of Python, next version of .NET Core. So if they go to deploy on that build server, and it's not out there, fails. So then what do they have to do? They have to go out to that build server and they have to install something, which is really scary. Because what happens if they install something and they break something, or those dependencies conflict? Now all of a sudden, you've got a bunch of groups that can't deploy their code. Container solves that problem. You deploy your container on the build server, and the build server only has to know about Docker. Solves those problems. What about density? Application density. What if I wanted to run, I had 5 servers in a cluster, but I had to have the dependencies actually on those specific nodes. Then I could only deploy those applications or services that met those dependencies. But if my servers just needed to understand the Docker container format, had to be viable Docker container hosts, then I can deploy unlike units onto those servers. And I can get vast amounts of density. And I can get more apps and services running on my machines. So hopefully, at a very high level, you'll have a decent idea of why you would care about Docker and why you care about containers and the ecosystem around containers. So what is Docker for? There are a couple Docker for offerings. Docker for Azure is something that's built by Docker, by the Docker Corporation. And that is a means by which you can easily deploy a Docker data center cluster out on Azure. And so you can go out there, you can search for Docker for Azure, and you can run it, and you can get a cluster up and running in Azure fairly easily. What's Docker for Windows? Scott talked about it this morning. Docker for Windows is a local environment on Windows that you can build containers, either Windows Server containers or Linux containers. So you have to have Hyper-V enabled, and then we've got a little virtual machine that's optimized for running containers, and you can run Linux containers on your Windows box. Arguably, it's the best Docker development environment out there because it's the only one where you can build both Linux and Windows Server containers. And so with that, let me show you a demo of running Docker for Windows. Jerry, there was some kind of trick. I'm not presenting anymore. I'm not sure what I did. Let me just unplug and plug back in. Ah, there we go. The voice behind the screen. Did you guys hear that? Windows P Luke. Okay, so here I am sitting on my Windows box. So this is a Windows machine. I have a little WAR file here. This is the world's worst Spring MVC app on the planet. It says hello world. That's all it does. It's a terrible app, and it took me about a day to write. It's my day with Eclipse. I remember it fondly. And I've got a Docker file. So let's take a look at that Docker file. So this WAR file, so I'm going to use this Docker file to create my Docker image. You can see its base image is a Tomcat image, Linux Tomcat image. I'm the maintainer. What I'm going to do is I'm going to copy that WAR file into the file system of my container, and then I'm going to tell it, at the end, run catalina.sh, which is an entry point for Tomcat. So at the end of the day, I've got this image that I can deploy onto any Linux-compatible Docker host and run it. So on my machine, I can do that. So now I have this file. It's called a Docker file. What I need to do is I need to create an image out of that. And for that, we use Docker build. So I'm just going to open up my regular command prompt, nothing else. I've installed Docker for Windows, and you can see that right down here. You can see the little Docker whale down there. I've got Docker for Windows. If I right-click on that, you can see all the options that you have. You can switch to Windows containers. I'm using Linux containers now. I can open up Kitematic. Let's do that. Let's open up Kitematic before I get going. Kitematic is a nice UI that's available for you to work with containers. So if you're not familiar, you don't feel comfortable working the command prompt, you can use Kitematic. So you can easily install that and run it. And Kitematic will allow you to deploy Docker images. You can view them. You can see what ports are mapped. So let's see if we take a look here. I'm looking at the Docker hub here. I can deploy an Nginx Hello World. I can deploy that just to my Docker for Windows, and I can see the logs running here. If I want to go ahead and take a look and see what this thing looks like, I can run it out there, and it's going to have mapped a port from my container over to my host. And you can see that I'm now running Nginx inside of a Linux container running under a Linux host on my Windows box. It's pretty cool. So I'll go back into Kitematic. I can kill this container. And let's go down to the command line, because the UI isn't kind of manly enough for me. So I got to go command line. So I'm going to go to the command line, and you can see I'm in the same directory as my Tomcat, as my war file, and my Docker file. So you can see I'm in same directory as my Docker file, so I'm just going to call Docker build. So I'm going to do Docker build. I'm going to give it a tag, and we'll call this my Spring MVC app. Okay, oops, I'm in caps. I'm going to give it a tag, -t, rbagb, Spring MVC app. I'm going to tell it to build in my local directory. And you can see super quickly, because I've already built it on this machine and everything's cached, my image was built. So I now have a Docker image, which I can run. I could take that image and I could push it up into a registry, which I'll show you a little bit later. But for now, I'm going to take that image, I'm going to run it on my local Docker for Windows environment. So I'm going to call Docker run, and I'm going to tell it to run detached, and I'm going to map some ports. So this container, it's meant to run on port 8080 inside of the container, and I'm going to map that to a port on my local host. So I'm going to say, look, port 8085, I'm going to map to 8080 in the container, and I want to call this thing test, and I'm going to run rbagb whack Spring MVC app. Minus name, sorry. Where were you guys on that one? So now I have my Docker container is now running, and I can actually get to it. You remember I mapped port 8085, so if I open up localhost 8085, and I put an HTTP in front of it, you can see I have the world's worst Spring MVC app running, and my hello world ran up. I don't want the technology of Spring or whatnot to get in the way of what we're doing. What I'm running is a Linux container in my Windows environment. So hopefully what you can take out of this is, if you do typically work in a Windows box, Docker for Windows is the easiest and best way for you to build containers, both Linux and Windows containers. If I wanted to switch from Linux over to Windows containers, I would just simply choose switch to Windows containers. But for now, let's jump back to the slides. Okay, let's talk about Windows containers. So the first support for Docker containers was obviously in Linux, and there were a bunch of facets of the Linux kernel that supported this, and we'll take a look at those in just a minute. We had to build those, or people smarter than me, but folks, engineers at Microsoft, had to build those abstractions into the Windows environment in order to support containers in Windows, and we've done just that. So now you can containerize Windows apps, and you get the same benefits you get out of containerized Linux apps. Now, there are two choices for Windows server containers. And these are one of these choices you don't have in the Linux world. So you've got Windows containers, and they offer you the same isolation that you get with Linux containers. How many of you heard the, hey, I don't want to use containers because they're not secure? How many of you are afraid to raise your hand that you've heard that? I hear that every day. The challenge that people have in general is that you're sharing the kernel. These multiple containers are sharing the kernel. Well, in Windows containers, you have that same challenge. You're sharing the kernel. However, Hyper-V containers resolves that, so you don't have a shared kernel. And so you have a an operating system per container, if you will, or you can think of it that way. Anyways, so you have two choices. When you're building a Windows container, you don't think about that. You just build it the normal way. And I'll show you what a Docker file looks like for a Windows container. However, when you deploy it, you choose which isolation mode you want. And you have benefits. There's plus and minus for each. Windows containers are lighter weight. You can spin them up faster. And they're smaller. You can get more of them on a machine. But you get additional isolation in Hyper-V containers. And incidentally, there's a great talk by a guy named Taylor Brown on Channel 9 if you want to get into the depths of Windows containers. So this slide gives you a high-level overview of the abstractions that you see in Linux and what we built inside of Windows. So the three main things that you'll see that enables containers, the three highest level, are AZGroups, namespaces, and the layered file system. We had bits and pieces of each of those in Windows, but we had to basically add some things here and there, and we had to kind of tie into the specification. And so what you'll see is, for control groups, we have job objects. We've added to our existing namespace functionality, and then we've created a layer that allows you to look at the file system as though it were layered, which enables containers. Now, what you'll see in Docker and the Docker specifications and what's out in Docker in the open source version of Docker that works with Windows Server containers, all of the changes that needed to occur to support both Windows containers as well as Linux containers, all of those changes are out in the open source Docker. It's not, when you use Docker, it's not one version for Windows or one version for Linux and then some kind of crazed other version for Windows. It's all the same thing. Okay? So we're moving towards parity. And so you'll have the choice, do I want to deploy a Linux container or do I want to deploy a Windows container? So I built these slides out to hopefully explain or clear up or talk to you about maybe how you might view container virtualization. So when you don't have any virtualization whatsoever, you've got some kind of hardware and you've got an operating system installed on top of that, and then you've got your application that's running on top of that. Then we moved into hardware virtualization, which is virtual machines. And so you have your hardware, and then you have this hypervisor, and then you've got these VMs that can have differing OSs running on top of them, right? I mean, we're all familiar with VMs and that level of virtualization. Now envision containers, and envision containers running directly on the metal, okay, directly on your hardware. Well, you've got a shared kernel, and those containers are carrying with them all of their application dependencies, and all of their own file system and your application. You can also run containers on VMs. So you have both types of virtualization. And that's actually what you get out in the cloud. When you're out in the cloud, when you're out in Azure, you're actually running on VMs underneath the sheets. And then you've got that shared kernel, and you've got these containers running on top of that. Now, what do you get when you're looking at Windows containers? Well, in Windows containers, you're not sharing the kernel as you would with those are Hyper-V containers anyways, as you would with regular Linux containers or Windows Server containers. Okay. So let's take a look at Windows containers. So what I have here is a classic .NET application. This isn't .NET Core. We're going to take a look at that later. This isn't what Jerry was showing you. This is a classic .NET MVC application that runs on Windows. And if we run it up, you're going to see this is using the basic MVC out-of-the-box template, and it wants to run in the Windows world. Okay? So we've got it up there. You can click around. We've all likely seen this. So let's close out of that. And let's go over, I've remoted into a box that's running Windows Server with support for containers. That looks like a Frankenbox right now. There we go. And so what I did was I actually have that app sitting up in GitHub, and I basically just did a git clone onto this machine, and I have this app. I have the entire app right here on this server. And I created this Docker file. And let's take a look at that Docker file. Okay, I can't zoom it into this thing because I'm not on Zoom. It's not installed on that remote desktop. So hopefully you can see it. At the very top, it says from Microsoft IIS. That's its base image. That's a Microsoft IIS image. So my MVC app wants to run on IIS. Then I'm installing Chocolatey, which is a package manager for .NET. Likely many of you have worked with that. And then I install a bunch of tools, some of which taking advantage of Chocolatey. So I'm installing all of the build tools that are required in order to build my application. Then I create some directories inside of my container. I copy the code over to my container, and you can see right here, I'm calling a NuGet restore to restore all of my dependencies, and then I'm calling ms build, and I'm building that SLN file, which, by the way, is an ms build file. So I build that all inside of my container, and then I basically copy all of the code to where IIS wants it running. Okay? So if I open up a command prompt here into that same location as my Docker file, and I call docker build -t, giving it a tag, rbagbywax sample app, and I tell it to build in my local directory, it's going to go ahead and run through and build all of that. And it builds it immensely quickly here because I've already built it and all of those layers are cached. If there were any changes, the cache gets thrown out and it has to do all of that work. Every line in here that doesn't have an ampersand connecting it from the last, it creates a new layer in that layered file system. And so each one of those layers is independent. And so whenever we see a change or whenever the Docker tooling sees a change, then the cache gets thrown out and the work has to get done again. So I did my Docker build, so I now have an image. So let's run that image on this server. I'll call Docker run, and I'm telling it, hey, go ahead and run this thing. I'm going to map port 8089 to port 80, which is what IIS is running inside of that container. So I'm saying map that port over to 8089 on the host. So now, because this is a server running out in Azure, I should be able to, I've just deployed my container into a Windows server on Azure, I should be able to go to that server's DNS name and then go to port 8089, and I should be able to see my app up and running. So let's try that. Granted, this is a lot less clean and cool than what you saw Scott Gu doing earlier, but I'm going to show you, as we move along, I'm going to show you some other options on how you do this in a more productionized way. I just want you to have a general understanding of how this all works. So let's go ahead and open up. And I think it's called Bagby deploy. Bagby Win Jenkins is my server. We can see where we're going. That's the URL. It's thinking about it. And there it is. My Windows Server app that's containerized is now running on a Docker host that likely doesn't have any of those dependencies that my app required. So I didn't have to install any of that stuff, whatever version of .NET is required by my app, or whatever version of any of the other dependencies. Now, granted, this is kind of a vanilla template, so there weren't a ton of dependencies. But I don't have to worry about any of those dependencies, because those are all encapsulated inside of my image that I deploy as a container. And I can very easily deploy that onto a host, which you saw. Cool. So I'm going to jump back to the PowerPoint. And let's talk about Azure Container Service. So now, before I jump into Azure Container Service, I'm going to talk about kind of what container solves and then what they don't solve. So I told you, to me anyways, the real meat is that all my dependencies are encapsulated. And that enables all of that, being able to run it on any Docker host. So I don't have to worry about what's installed on the server that I'm putting it into. That means I can get high degree of application density. It means that I can easily do CI/CD because I don't have to worry about what's on my build server. I get all of that. It works on my machine. I build it on my machine. I deploy it, and I know it's going to work. I don't have to schedule downtime for my deployments. I get all that. So then you get into, and I heard Jerry talking about microservices. So then you start saying, okay, well now, let's start breaking our app down into a bunch of little services. bunch of logical services that each have their own storage, so I can have optimized storage for for the purpose of that service within my application. The example I use is a video site. If I have a video site, which I do, DevEducate, if I have that site and it has certain functions, one of it is search. I want people to be able to search to find whatever video they want. Do they want one on Azure Container Service, or do they want to find a video on Code Katas or whatever? So I've got search, that may be one service. And then maybe I've got another service that tracks what people are doing out on that site. And if there are a lot of people out there, I've got to store a ton of information. Well, in search, what's the storage I would typically use for search? I might use Azure Search or Lucene. If I want something that's going to manage a high degree of scale for a massive amount of partition data, maybe I want to use Cassandra or DocumentDB or Mongo. What if I want to store the actual metadata around each of those videos? Maybe I want to use JSON to do that, so I want to use Mongo or DocumentDB. So I want to have different persistence, and maybe I want to have different services that sit on top of those. And so I start breaking my app down into what we're calling today as microservices. Basically breaking your app down into a properly architected bounded context. Now I've got a ton of services out there, and I've containerized them all, so I can manage those. And I've got all these containers. Now I get a whole new set of problems. How do I make sure those containers are up? How do I know those containers are deployed on hardware that they require? How do I know that that container gets onto a host that has 2 gig of memory that it requires, or it has N amount of CPU? How do I handle all that? What happens when one goes down? How do I scale it out? How do I make sure that when one goes down, it goes back up? How do I make sure that if it's using storage, it reattaches to that storage? How do I monitor it? All these are a massive set of challenges that you have once you buy into containers. You had them anyways. But now that you've broken your app down, it becomes really clear. So that's the role of orchestrators. I'm sure you guys have heard of many of these. Kubernetes, DCOS, Docker Swarm. That's their role, is to solve those problems. And they all do it in different ways, but they all support containers. Okay? ACS, Azure Container Service, is basically our means of deploying out the open source versions of those orchestrators in a proper fashion. That's what it is today. So if you're familiar with Azure, how many of you know what an ARM template is? You poor, poor souls. An ARM template is a big, ginormous thing of JSON that defines the topology of what you're deploying into Azure. It's our means by which you can say, hey, when I go to deploy whatever it is, this is the JSON that represents that topology. And if you're not building that JSON yourself, it's really awesome. If you're building that yourself, it's really painful. What Azure Container Service does is it essentially behind the scenes builds a proper ARM template for you. So imagine you wanted to work with an orchestrator, Mesos and Marathon, for instance. And you wanted to deploy that out yourself, out into Azure, or AWS, or Google, or wherever you want to deploy it, or into Rackspace, or wherever. If you want to deploy that, the first thing you have to do is you have to deploy all of the kind of virtualized hardware. You have to, I need these VMs, and they need to be in these subnets, and I need these load balancers, and I need these scale sets. And by the way, I need to have a private cluster and a public cluster, because I need to protect myself. This needs to be done using best practices, right? So you might finally get that deployment complete. And once you get that deployment complete, now you've got to install the software on top of it and get that working all together. That's the problem that is solved by ACS. We give you an ARM template and allow you to deploy that ARM template that allows you to deploy a cluster, a Mesos cluster, DCOS, which is Mesos and Marathon and Kronos, or a Swarm cluster, or a Kubernetes cluster, and we'll do it properly. We work closely with the companies that are building those technologies. I have a weekly meeting with Docker and a weekly meeting with Mesosphere. We worked with those folks to make sure that we're deploying properly deployed clusters. Now, ACS is all open source. We will not allow anything into ACS that isn't 100% open source currently. I don't know what the future holds, but right now everything in there is open source. And we do that for a really important reason, because we want to make sure that whatever you put into ACS is portable. What if you want to run it on premise and you want to run it in ACS? It just works, because you can deploy the open source version of Mesos, DCOS, or Swarm, or Kubernetes, or whatever it is. You can deploy that on-prem and run exactly as you're running in our world. And so that's kind of that's the bar that we've set in ACS. Now, if you want something on top of the open source versions, Docker has Docker Data Center, there's Enterprise DCOS. If you want one of those offerings that adds bells and whistles on top of it, and a different degree of support, you can do that. You can do that on Azure as well. But ACS is the open source version of those orchestrators. So here's a view of, I believe this is a Mesos cluster. But you can see this is basically what the topology looks like in Azure. You can see you have 3 subnets here. The one on the far left, that's for your masters. And that's where you're going to be doing all of your, where you're going to communicate and say, hey, I want you to deploy this workload, or stop this workload, or scale this up. That's where you're going to be talking to the CLI, and you're going to be saying, hey, deploy this. Okay? That's on the left. And then over here, that's your public. These are your public workers. And that's where you're going to deploy things like load balancers. Not very much of your workload gets deployed into this public cluster. It's mainly load balancers. Things like Marathon LB or HA proxy. And then on the very right side here is this private agent. This guy right here. That's where most of your stuff is going to get deployed. And then this guy here, sorry. This guy here, I lost my, right here, he's going to be load balancing in front of those guys. Why do we do that? Why is that how you want to do it? Well, if you deploy your own virtual or software load balancers, like HA proxy or Marathon LB, inside of that subnet, then all of a sudden my entire workload is portable. If I had like an Azure load balancer that was inside of my cluster, then all of a sudden, how am I going to take that same code and that same environment and move it on-prem or into my data center or wherever I want to run it? That's the reason why you would typically, you've got an Azure load balancer up there sitting in front of everything, but then it's going to walk down into your load balancers, right? Oops. I didn't lose it. But it's going to run, basically, you're going to have your load balancers right in there. So with that, let's take a look. I'm still good. So let's take a look at Azure Container Service, or ACS. So I'm going to bring up the portal, portal.azure.com. It takes about 12 minutes to deploy an ACS cluster. I had a full set of hair before I tried to deploy one myself. That'll give you an idea of the amount of effort that's saved. So I'm just going to click New. I'm going to choose Azure Container Service. Click Azure Container Service. It's going to walk me through some of the choices I need to make. And I'll go through a good bit of this. So I need to create an admin name. I need my SSH public key, so I can go grab my public key. Try not to memorize this as I start to grab it. So let's see. There you go. See, this is all on purpose. So I'll grab my key. Again, please try not to memorize that. Got my key. I can go out enter in a new resource group. A resource group, by the way, in Azure is a means by which you can organize resources. So I can add a new resource group. I'll create one called BagBFred, something like that. And the location. Where do I want to deploy that thing? So I'm going to deploy it into the West US. I'm not going to actually deploy this thing because it takes 12 minutes. I'll show you what it looks like. Here's where I choose the orchestrator. So I can choose DCOS, Kubernetes, or Swarm. Now you can't change this later. You'd have to redeploy. But I'm going to choose, we'll choose DCOS here, just for giggles, because it's on top. And when you guys said you couldn't read it, was that an angry, we can't read it, and you should be zooming more? Was that like, okay. Oh, oh yeah, that is kind of, yeah. I would be angry if I were you. Right on. I feel your pain. Just to make you feel better, it's crystal clear for me. All right, so here's where I choose. You want me to change the resolution? I got to walk through these same things Scott Gu did here. Let's see, display settings. What did he do? 1080? Where is it? On the right? Down? No, it's not. There's too many people. One at a time, please. What? Technical help? I'm going to let somebody smarter than me do this. Ah, there we go. Why don't you guys just say so? There we go. Is it good? Can you see it now? Cool. Hey. I wish I had him behind me at work. All right. So let's see, where was I? I was in the portal. Okay, so now I can choose, here's where I can choose the number of agents I want, and these are the private agents inside of my pool, and the number of masters I want. That's how I can achieve HA. Okay, so I'm just going to choose 1 and 1 for this, and here's my DNS prefix, and that's for my container service. And so if I chose BagBFred, the DNS prefix for my agents would be BagBFred agents, and for my master might be something like BagBFred master. So we'll just call it BagBFred for now. And click OK. And now we get a summary, and we deploy. Easy peasy, lemon squeezy. About 12 minutes from now, a cluster, a properly defined cluster, is going to be up and ready for me to work with. So, as any good cooking show host would tell you, it's best to have one of those already built behind the scenes. And I do. So I'm going to show you, go into my resource groups, and the very top thing you'll see, which you can now read because we've changed our resolution, and somehow I've changed the color of the circle thingy, is BagB ACS Mesos. And let's take a look and see everything that was deployed into this, because there's a lot of resources that got built. Look at all that. If we organize it by type, you can see we've got an availability set, we've got load balancers, we've got one of those load balancers is for my agents, one of them is for my master, I've got network security groups, public IP addresses, etc. All of that was deployed for you. You don't have to worry about the complexity of it. So what we want to do, because I've deployed a Mesos cluster, what I want to do is I want to SSH into my master, and I want to create a tunnel. And that's going to allow me to work with that master so I can deploy applications into my cluster. And I'll tell it, deploy into either the private pool or deploy into the public pool. And let's do that. And I'll show you a couple of different ways which you can deploy into that Mesos cluster. So what I need to do is I need to SSH into that. If you're not familiar with SSH and you start working in Linux, you're going to have to get familiar with it. In Windows, one of the tools you can use is PuTTY. And so I'll use PuTTY in order to SSH into this node. I'm going to put my glasses on so I can see. And so what I want to do is I want to get the IP address, the public IP of my master. So I'm looking at this master here, and I'm going to choose this guy, and I'm going to get its public IP. I can also use its DNS name, by the way, and the DNS name won't change, so maybe I'll use that. So I'm taking its DNS name, BagB ACS Mesos Management, dot blah, 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 and I'm just copying that. So now I'm going to open up PuTTY. And PuTTY's going to allow me to create an SSH tunnel. So I'm going to tell it, hey, I want to SSH into that DNS name on port 22. And I need to tell it, hey, what's my private key so I can authenticate? So I'm going to choose my private key, and then I'm going to create a tunnel. So I'm going to say, I need to basically map from localhost 80 over to port 8080 on my machine. So I'm going to click open. It's going to ask me, hey, who are you logging in as, and what's the passphrase for that private key? Bang. I now have a tunnel open. So now I can go ahead and open up a browser, and localhost is now tunneled into that Mesos cluster, into that master. So I can do localhost 8080, and I'm going to see the Mesos UI. Ah, that's unfortunate. All right. Let me close this down. The fastest way to debug this is to do it twice. So I'm going to go ahead and open up that tunnel again. Let me get that. The IP address. Go back into PuTTY. Private key. Cool. Add the tunnel. Oh, I know what I did. I do this every time. If you don't click add, it doesn't get added. Remember that. No add, no add. And so now I click open. Yes. VM admin. Okay, we're now tunneled in properly with the tunnel, actually, and this should work. And it does. And you can see that I'm now looking out on Mesos here. And I can see that I have nothing going on in my cluster. I think I have three private agents out there and then one in my public pool. I have no apps deployed whatsoever. But I can go ahead and deploy out into it. Let's deploy a load balancer into that public agent pool. Okay? And then I'll deploy something into my private agent pool that will then be load balanced for me. So I can go ahead and use the universe. We were kind of joking about the name backstage. What's the icon for universe? It seems like it's fairly lofty. But I'm just going to choose the Mesos universe, and I'm going to choose Marathon LB here. And there's a Marathon LB, and I'm going to click install. I'm going to install out of the box choices, and then I'm going to take a look at my services, and you can see it's now up and running. So now I'm going to go into Marathon itself, which is different than Marathon LB. I'm going to go into Marathon, and I'm going to deploy one of my services into the private agent pool, okay? Into that cluster of private agents, and I'm going to tell it, I want you to use that load balancer to load balance it. So what I've got is a little JSON file. Let's see if I can find it. I've got a little JSON file that I'm going to copy, and I'll show it to you. And I'm going to deploy. I'm going to choose Create Application up here on the right. And I could either walk through all of these choices here, which would take me a little while, or I can go into JSON mode. I'm glad my name's not Jason. I go into JSON mode. Sorry, Jason. And you can see here's what I've chosen to deploy. I'm using this image, rbagby Spring MVC app. That's that stupid app that you saw me build earlier with the WAR file that says hello world. I deployed that out to Docker Hub. So this is saying, hey, pull this out of Docker Hub. That's the image I want to use. And I'm telling it down here, I want to use an external proxy, and I'm pointing it over to the DNS name for my public agents. That's the magic. And somewhere in here, I've told it, I want a scale of 2. Right there. I want 2 instances of this thing up and running. Okay? So I'll click Create Application. Now all of a sudden, this thing's out and deploying. And one of those applications, if one of those services were to die, or one of those nodes that's housing one of those services dies, DCOS is going to know that, and it's going to deploy it onto another node that's up and running. It's going to do its best to keep what I've configured, what I wanted it to do. And I don't have to worry about that. So I'm basically telling it, here's the topology of what I want, you make it so. Now, it's obviously infinitely more complex than that. And each of the orchestrators have their own kind of knobs to turn. But you can tell it, hey, I've got this, I can put attributes and tie attributes to hardware and say, hey, this hardware has GPUs. And so when I deploy, I can say only deploy to nodes in this cluster that have GPUs. You can do all of that work. But this just gives you an idea of these guys running. So it's now out and up and running. And so if I were to go to the DNS name for that public agent pool, I'd be able to see those nodes. I'd be able to see my stupid app. Bagby, what's it called? ACS Mesos agents. There we go. And there it is. That is my stupid Spring MVC app running inside of a Mesos cluster. And if I were to refresh it, it would then be going round-robining across those n number of nodes. If I wanted to scale it, I can simply go into the UI that was available to me and make those changes to tell it to scale up to 3. There are multiple ways in which you can interact. You don't have to use the UI. You can use a CLI. You can use REST endpoints. But hopefully, you've gotten enough of a view into what ACS is to whet your appetite. I've got to carry on because we've got a couple other things we want to take a look at. Running .NET on Linux. I'm not going to go into this in any more detail because Jerry talked about it fairly for over the course of an hour. There's nothing I can add to that. What I can do is I can take that same cluster that we had running out there, this guy right here. I can go back into DCOS. I can kill that Spring MVC app. Wait till that is done, so that's out. And I can go to create an application, and I can go back into JSON mode, and I can go ahead and take a JSON file for my .NET Core app, which I'll show you in a second. You can see here, I'm using another image called our Bagby Whack Products Web, which is my .NET Core app. I've told it again, hey, the container port is 5,000, but the host port is 0. That means I want you to use a load balancer in front of this. I want you to handle this for me. And again, I've set up the external HA proxy host. So now if we go ahead and deploy this, I'm taking a .NET Core app, and I'm deploying that out into a Mesos cluster, which is Linux-based. Okay? And we'll see it going here in a second. As soon as it says it's up and going, we'll go back out to that URL, and we'll see that little MVC.NET Core MVC app up there. Looks like it's running, so let's take a look at it. Back out here, let's get rid of the Whack Products Web, delete, return, and bang. There's my .NET Core app running in Linux with DCOS as its orchestrator. And if one of the nodes went down, DCOS is going to bring it back up onto another node for me. Cool. So that's .NET on Linux. We've got a couple more topics. I think I got about 10 minutes, which probably should suffice. Enterprise solutions, really quickly. If you want to go beyond what you see in the open source version and you want those extras that are very viable out in the world, then take a look at Docker Data Center or you can take a look at Enterprise DCOS from Mesosphere. If you need contacts from any of those people, send me an email. I'll get you in contact with the right people. The last thing I want to talk about is CI/CD, because this is a fairly popular use or use case of containers. Scott showed it in Visual Studio. I'm going to show you a different version. This is more kind of this is more in the traditional, outside of kind of the Microsoft world, but I wanted to tie it back to Windows Server containers. So what you've got is, for me, I've got code that I'm writing in whatever. And for me, I'm writing it in Visual Studio. I'm pushing it up into GitHub, into a public repo. Inside of Git, I've hooked up a webhook into Jenkins. If you're not familiar with Jenkins, very popular build server. Jenkins and Travis, TeamCity, VSTS, things like that. Those are kind of the big boys. So I'm using Jenkins. Inside of Jenkins, that's where you see this little box down here. This is the cool part. This is the money. This is where you pay attention. There's a couple ways you can set up your builds. And there was a guy getting up about ready to leave, and I said that. That's cool. I have a massive amount of power now. You could either install on your build server all of those dependencies required in order to build your solution. Let's say I'm building a Go application. I've got to have Go installed on that thing. I was just doing this last week with a colleague of mine. He wants to do a build for his Go application. And he said, all right, well, let's get Jenkins up and I'll install Go on it. No. What you can do is you can then just have a Docker image or a Docker file that deploys with your code. It builds a Docker image. The Docker image defines that Go is a dependency. Called Docker build. You build that image, and now you run it. And so now I can compile inside of my container, not on the server itself. So I don't have to muck up my build server. And so that's what I've done in this example here. So let's see it go. The next step, after we do the Docker build, Docker run, I run my tests inside of that container, my unit tests anyways. If they all pass, I call Docker push to push into Docker Hub. And then I can deploy from Docker Hub out to my, say, staging server if I wanted to. That's the pipeline you're going to see here. So let's go ahead and take a look at that in action. So I've already deployed this application out onto my quote-unquote staging server. So you can see it says ASP.NET. It's the same ASP.NET app we've seen a few times. Okay? So now what I'm going to do, you can see I've got a Jenkins build here. I'm going to show you that build in a second. You can see that I've had 12 builds on this thing. What I'm going to do is I'm going to check in some code. When I check in that code, let's make a change to this app. So let's see here. Give me a second. Okay. Okay. So let's make a change out here. Instead of that ASP.NET we saw out there, let's just call this, I don't know, hello AZGroups. Okay, let's save that. This is a stupid change. This, wouldn't require a full test suite to run. But I'm just going to illustrate what this would look like. So let's do a git status. So you can see I've got one change in there. It's really probably hard for you to read that, but there's one change. I'll do a git add. I'll do a git commit. And I'll do a git push. Okay, this push is going to go ahead and push it up into GitHub. The webhook is going to kick off. And behind the scenes, what you're going to see is a new build has started. This build, as it goes, is going to take about 5 minutes. So I'll show you the build as this thing is going. What it's going to do is going to pull that code down from Git. And then it's going to build a Docker image from my Docker file. It's going to call Docker run inside of that image. Inside of there, it's telling it, run the unit tests. It's going to run the unit tests. If everything passes, it's going to call Docker push to push up into Docker registry. And then it's going to call deploy through Docker Compose to push out to that staging server. All in this one build. So let's go ahead and take a look at the build as it's running and see where the magic is. It's considering my request to configure it. So you can see up here, here's where I've told it, my source code repository, here's the repo, control 1, there you go. Now, I've also set up a build trigger, so here's where I've set up that webhook, bang, that nice yellow washed out color. And then I've walked through, and here's where the money is. Here's where I'm starting to actually do the work. The first thing I'm doing is calling docker build, and I'm building this entire solution. And so that's where that Docker file I showed you has all of the dependencies inside of it. So it's building up and compiling my application, bringing down all the dependencies, taking advantage of, taking Chocolatey and building all and grabbing all of those dependencies that are required. The next thing you see down here is this Docker run. And this is actually the kind of the most complex piece of this thing. What I did was I called Docker run. I'm telling that container to go up and run. But at the end of this command, well, you also see I've got a --rm telling it when you're done running, delete yourself. I've mapped a volume. I'm getting way too in the weeds here for you, but in case you're interested, I've mapped a volume which says that when it writes its test results out, I'm telling it, have those results available to the host. So my build. So the test results can be read by my build. But at the end, what you need to really kind of see, the money in this thing is, somehow I can't scroll over to the right. Well, you'll have to trust me. In the end, I'm telling it, run a command on this thing to execute those tests. Do I have 3 or 4 minutes left, Scott? So to run those tests. This is kind of the, of what I discussed with you, the ability to encapsulate your dependencies inside of that container. This is a representation of that. My server itself didn't have to have any of the dependencies that were required by my application. And in this case, I'm able to run my tests inside of my container and get the results out. Make sense? I've kept my container or my host from getting mucked up at all. Let's see how this thing is moving along. Still running. As it finishes up, I've told you it's going to go out and it's going to get pushed into, why is this thing offset to the right? That is the oddest. No, I don't know how to adjust that, obviously. So it doesn't matter. I'll never figure it out in that short period of time. We've reached the end of my configuration capacities in Windows. Again, I'm never going to get it. I can't stress that enough. So as this build finishes up, what we would see, we're able to do that, is if we went out into GitHub, or excuse me, into Docker Hub, you would see a new image that got pushed into Docker Hub. And then off of that new image in Docker Hub, I would have pulled that down, and then I'm going to push it out into this app, into this staging server, which we will be able to see. So as soon as this pops done in the next, probably looks like 30 seconds, it'll go. So let's just take a quick look out here. So there's Docker Hub. Hasn't been pushed into Docker Hub yet. We'll see it in a second. We should see a new tag get pushed into here. This says 4 hours ago right now. And I'm doing the same thing Scott was doing earlier, waiting for the step that normally doesn't take as long to run. Do you guys hear that? It's like the telltale heart. I feel guilty that my app isn't running. The build is still going. It's not read yet. Still going. Should I jinx myself? In 10, 9 3/4. It'll finish up in a second. Again, the benefits here are, and this isn't without, there are reasons why you might not want to do this. A lot of people claim that containers might get overly bloated by having all of that test code deployed into your container. Personally, the value of being able to encapsulate the dependencies in that container, including the tests, to me outweigh that. I find it a very clean way for me to never have to really monkey with my build server. I normally wouldn't have done a deploy directly within this build from Docker Hub out to a staging server. That's typically where you would have another webhook, and I would have a second build. So you'd have a webhook that's listening in on what was deployed out to Docker Hub, and then another job would kick off, which would typically deploy a bunch of containers into a staging server and run integration tests against it. But alas, I didn't have time to do all that. You can see the build completed. Let's go ahead and refresh this, and we should see our updated code, which is, I forget. If I go over here into Docker Hub and refresh this, we'll see another. You can see we had another build a minute ago, which this tag is the same tag as was in Git, and my new code, hello AZGroups. So, thanks. So that is, thank you. That's really it. That's amazing that worked. That's really it that I have today. If you have any questions, you're welcome to reach out to me via email. Again, my goal was to hopefully give you a high level on what containers are and why you would care, and then what some of the tooling you can take advantage of and when you might take advantage of different pieces. So when you're building locally, where you get started, start with Docker for Windows if you're on a Windows box. If you're on Mac, you can use Docker for Mac. And just get started building your containers. Then when you need to start growing and starting to deploy, well, you can start taking advantage of some of the technologies that Scott showed you in our container support in Azure in our apps. Beyond that, once you start growing out of that, then you start looking at the orchestrators and start looking at Azure Container Service.
What do you guys think? Good? Helpful?